A swirl of clouds appears on a satellite image. Winds roar across the ocean, capable of flattening entire cities. Waves rise high enough to swallow entire coastlines. Hurricanes are among the most powerful forces on Earth, and they seem to be getting stronger. And this is why. Hurricanes, known as cyclones or typhoons in different parts of the world, begin as clusters of thunderstorms over warm ocean waters. When the surface of the sea heats above about 26 degrees Celsius, the conditions are just right for these storms to form. Warm water evaporates and rises into the atmosphere. As it condenses into towering clouds, heat is released. This heat drives more rising air, which lowers the surface pressure and draws in even more warm, moist air from the ocean below. The Earth's rotation then sets this rising column of air into a spin. Over time, the storm organizes into a giant heat engine, spiraling bands of thunderstorms wrapped around a calm, eerie center called the eye. Surrounding it is the eye wall, a ring of violent storms where the strongest winds and heaviest rains occur. A fully formed hurricane can stretch hundreds of miles across and release more energy in a single day than all the world's power plants combined. But in recent decades, hurricanes have been getting stronger, and one major reason is climate change. The warming atmosphere leads to warmer oceans, and warmer oceans provide more fuel for hurricanes. With more energy available, these storms can grow larger, spin faster, and unleash far more rainfall. Warmer air also holds more moisture, meaning when hurricanes make landfall, they can dump staggering amounts of rain in a short time. Rising sea levels add another layer of risk. A storm surge that might once have flooded a low-lying road can now reach entire neighborhoods and cities. Research shows the number of the most intense hurricanes, Category 4 and 5 storms, has increased over recent decades. While the total number of storms worldwide hasn't changed dramatically, their strength and rainfall have become more extreme. Another troubling trend is the slowing down of storm movement. Some hurricanes now linger over the same region for days, unleashing catastrophic flooding. Hurricane Harvey in 2017 dropped more than 60 inches of rain on parts of Texas, the heaviest rainfall event in US history. When a storm stalls like this, the ocean below continues to fuel it while communities on land endure unrelenting wind and water. The dangers of hurricanes extend far beyond their winds. Lightning strikes and tornadoes can form within their thunderstorms, adding sudden bursts of destruction. The most deadly feature of many hurricanes is storm surge, a massive wall of ocean water pushed ashore by the force of hurricane winds. In 2005, Hurricane Katrina's surge overwhelmed the levees of New Orleans, causing devastating floods that changed the city forever. Even outside of the eye wall, strong straight-line winds can topple trees, tear off roofs, and knock out power to millions. Yet hurricanes are not purely destructive. They also play a role in Earth's climate system. By redistributing heat from the tropics to higher latitudes, hurricanes help balance energy across the planet. Lightning inside storms even fertilizes the soil by producing nitrogen compounds that return to Earth with the rain. They are violent, but they are also part of the planet's natural way of redistributing heat and nutrients. Meteorologists have made enormous progress in predicting these storms. Satellites monitor them from space, Doppler radar measures rainfall and wind patterns, and powerful computer models simulate their paths using vast amounts of data. Today, forecasters can often predict where a hurricane will make landfall days in advance, giving people time to prepare or evacuate. This has saved countless lives compared to storms of the past. But predicting how strong a hurricane will become remains far more difficult. Rapid intensification, when a storm's winds increase by more than 35 miles per hour in just 24 hours, is especially dangerous. A storm that looks manageable can suddenly explode into a monster just before landfall, leaving communities unprepared. Climate change has made this phenomenon more common, making the work of forecasters even more urgent. History reminds us of the devastation hurricanes can cause. The Galveston Hurricane of 1900 remains the deadliest natural disaster in US history, claiming an estimated 8,000 lives. In 2005, Hurricane Katrina killed more than 1,800 people and caused billions in damages. In 2013, Typhoon Haiyan struck the Philippines with winds over 190 miles per hour. one of the strongest landfalls ever recorded. Each of these storms left scars that shaped not just landscapes, but the societies that endured them. Looking ahead, scientists warn that stronger hurricanes will become the new normal. Rising seas and warming oceans will continue to feed storms, making them more destructive and more frequent in their extremes. Billions of people who live in coastal cities will face higher risks of displacement and devastation. The question is no longer whether stronger hurricanes will strike, but how prepared we will be when they do. A hurricane is more than just a storm. It is a reminder of nature's raw and unrelenting power. From space, its spiraling clouds look beautiful, almost perfect. Up close, it can destroy homes, rewrite coastlines, and change history in just a few hours. And as the world warms, these storms are becoming even stronger, testing the limits of human resilience. And this is why hurricanes keep getting stronger.